Hi guys, this is a presentation on straight line graphs or linear graphs. Okay, so the objectives of this session are we're going to discuss the straight line graph formula, so y equals mx plus c. We're going to plot our given data on a graph, and then we're going to calculate the gradient of the line produced from that data, and then we're going to use the data or what we've calculated from drawing our graph to work out an unknown. Okay, so the straight line graph equation slash formula. Okay, so it's y equals mx plus c is the formula, and that describes the relationship of what's happening within our straight line graph. Okay, so a linear equation produces a straight line graph. Okay, and when we use the experimental data or the data that we've collected to plot a graph, okay, if it's a straight line, we can use this formula y equals mx plus c to work out the relationship between the y-axis and the the y-axis and the x-axis. So what does each one of these little components mean? Okay, so we've got y, so y is the vertical axis. Okay, so the data on the vertical axis. M is the gradient of the line, so how steep that line is. Okay, how steep the line is, so that's the gradient. We have x, which is the horizontal axis, and then lastly we have plus c. Okay, so plus c, or it might be minus c depending on the graph that you're producing, okay, is the point at which it crosses the y-axis. Okay, so that's the intercept point, so when it crosses the y-axis. Okay, so at 0, where it crosses from 0 into a negative number, okay, or a positive number, that would be the c, whatever c is, whether it's plus or minus. Okay, whether it's, so that would be a figure on the y-axis. Okay, so if say for example it's down here, okay, the straight line's down here, the c will be a negative, but the ones we're going to be doing are all going to be positive. So we mentioned that a straight line graph is produced from a linear equation. Okay, so an example of a sort of a practical linear equation is our Ohm's law formula. So we have voltage equals our current, which is I, times the resistance, which is R. So voltage equals I times R. Now, if we're doing some experiments, for example, okay, we want to sort of work out what the voltage will be if the current remains the same, but we alter the resistance. Okay, we can do that by sort of we can do it mathematically. So we know that using this formula, we know that if we keep the current stable at 2 amps, okay, and we change the resistance each time. So in our first experiment, we do 2 amps times 1 ohm for resistance. Okay, we get 2 times 1 is 2, and then we change it again. So on the next experiment we change it to 2 ohms. Okay, 2 times 2 is 4, and then on the next one we change it to 3. 2 times 3 is 6, and so on and so forth. Okay, so as we can see from that, if we were to plot this data, okay, so this would be our y-axis. Okay, this would be our x-axis. Okay, so resistance will be on x, the voltage will be on y. M, which is our current in this case, okay, the gradient would be our 2. Okay, so 2 would be M, and that's how that sort of our linear or our straight line graph formula relates to our linear formulas. Okay, our linear engineering formulas. Okay, so that might be power, okay, which would be current times voltage. Okay, you know, any sort of linear equation. Okay, so it might be speed, distance, time, and stuff like that. Okay, they'll have a relationship that we can use this formula to plot them on a graph, okay, and make sense of that data, and then we can start looking at calculating unknowns. Okay, so the next step of this presentation is we're going to look at an example question. Okay, so you're going to get a question in your assignments or in your test or something like that, and it's going to be using the data supplied accurately. Okay, and I need to emphasize this. Okay, having something that's drawn without a ruler, you know, all scrappy and horrible, you're not going to award any marks. So it needs to be accurate, it needs to be neat, and it needs to make sense. Okay, so accurately draw a graph that represents the data. Okay, so the data given is this down here. We need to calculate the gradient, which is m, establish the y-intercept point, and then we need to calculate an unknown. Okay, so we now need to calculate what y would be if x is 31. Okay, so what we're doing here is, so we're going to sort of look at what x is up here and find out what the y is. So I've done this using Excel, so I've produced a graph on Excel. So accurately draw a graph that represents the data. Okay, so here we've been given our x and y axis. Okay, so it was easy for me to plot. Okay, so I've got they jump up. Okay, I've done it on Excel, but you're going to get graph paper like this, and you're going to have to either draw it in pencil or pen, preferably pencil, because then if you make a mistake, you can rub it out rather than just scribbling it out. So the y-axis is the vertical axis, so that'll be going up in this direction, and the x-axis is going in this direction. One thing we need to make sure is that both the scales on each side are constant. Okay, so that they're so there's a constant sort of either width or gap between each one. Okay, so say for example on your squared paper, if you go 0 here and then 1, 2, 3, okay, and put 3. The next time you need to go 1, 2, 3, and 6 again, okay, instead. But some people have made the mistake of going sort of like 3 and then only putting 2 and then going 6 and then sort of going 3 and putting 9 and then sort of 2 again and going 12, and it just gives you an untidy graph. Not only that, it can make it difficult to accurately gauge the intercept point when it comes to y. Okay, not only that, it's wrong as well. So, and you won't get the marks for that. Okay, so I plotted my data for x along the bottom on the x-axis, so it goes up 3, 6, 9, 12, 15, and 18, and then I plotted my results for y. Okay, so at 3 going up, okay, along the y it hits the y-axis at 5.05, okay, 6, 6.1, 7.15, and so on and so forth. Okay, so you need to accurately draw a graph. Okay, plot the data. Okay, make sure it looks neat. Okay, and then you can start looking at calculating the gradient and the y-intercept point. One thing I would say is you might get data that this data here fits perfect. Okay, this is a very accurate straight line graph, but you might get something where you'll get experimental data, and you might have to the line you put in might be a line of best fit. Okay, so there might be some sort of like variations in between. Sort of you might get a couple of results which are slightly off, but you have to sort of create a line of best fit, so we're sort of getting an average, for example. So that's our graph. Okay, so once you've drawn your graph, we need to calculate the gradient m. Now, some people find this confusing, but what we need to do is when we pick up our gradient m, we need to pick 2 points on the x-axis. So we can put, say for example, x-axis here, down here, okay, and then x-axis down here as well. So say for example, if we're going to use 3 and 15. Actually, no, we'll go 3 and 18. So we'll pick the two extremes of our data. So we're going to have, so it's going to be, this will be 3, and then we'll move it along and pick up the y-axis. So it'll be on the x it'll be 3, on the y-axis it'll be 5.05, and then we'll come down to this end and it will be 18, okay, all the way up, and then on the y-axis that will be 10.3. okay, and now so the formula for that, it's the difference in, so this little triangle sign there, that's a Greek letter, and that stands for delta. Okay, and it usually means the difference. Okay, so it's the difference between, say if this was x1 and x2, it's the difference in x, okay, and then the difference in y. Okay, so I've picked 3 and 18, okay, and their corresponding y-axis points. Okay, so it's going to be the difference in, so it's 10.3 minus 5.05 divided by 18 minus 3. Okay, and it is always the data on the y-axis divided by the difference of the x-axis, so difference in y divided by the difference in x. So then once we do that, we look at that, so 10.3 minus 5.05 equals 5.25. 18 minus 3 is 15. Okay, and so 5.25 divided by 15 gives us our 0.35, and that is m, so that's our gradient. Okay, and as we can see on this graph here, that the c is the y-intercept point, wherever that may be. Okay, so when you do your diagram, okay, or your graph, shall I say, you haven't got 0 on the graph. So what you're going to have to do is then extend your straight line through and tell me where, or establish where c is, or what c is, should we say. Okay, so you would extend your straight line all the way through your graph, okay, nice ruler, nice and straight, and tell me where it intercepts, okay, the y-axis, and that will be c. So for our graph c is 4. Okay, so for this data, so we've got our c, we've now got m. Okay, what we need to do is just test that. Okay, just check to make sure that, you know, you can punch this data back in and you can get back what you already know. Okay, so we're just going to check to make sure that c is at 4 is correct, and that our gradient at 0.35 is right as well. Okay, so we're going to go back to our formula, so y equals mx plus c, and we're going to plug this back into the data that we already know, so that we can check to make sure that we're on the right lines, okay, before we go on to the next step, which is working out our unknown. So we're going to take we're going to do 9. Okay, we're going to use this point here, so we're going to use x as 9. Okay, so we know y, well, we're looking for y, and it's equals m, which is our 0.35, times 9. Okay, because we're using that on that, and then we're going to plug in our plus c, which is 4, and so we work that all out, and it's 7.15. okay, and that's what we've been given, so that we know that our data there, so our m is correct and our plus c is correct, our c is correct. Okay, so we have the right data now. So now what we can do is we can actually go forward and calculate y if x is 31. Okay, so this could be anything. It could be resistance, time, temperature. Okay, I'm just using x just for the x-axis. Okay, but that could be anything in your question. You might be asked to find the resistance if temperature is x, or if, you know, the voltage of x is y, or whatever. You know what I mean? It's all about just sort of making sure that you've got the right, you're picking the right components to go on the x-axis, and the right components to go on the y-axis. Okay, so now what we're going to do is we're going to calculate y if x is 31. Okay, so now we're looking at down here somewhere, so we're going to have x at 31, and it is simple as y equals mx plus c, and we just plug in our data that we've got. So we're looking for y, and we've got our gradient, which is 0.35. so our gradient is our constant. Okay, it's non-changing, it stays exactly the same. Okay, and then times 31 plus 4, okay, and that gives us 14.85. okay, and that is it. Okay, so hopefully by the time you finish this question, you should have a nice neat graph. Okay, good positions. Okay, so the scale between the two, so if, say for example, this is on squared paper, you'd have 2 squares between that one, 2 squares between that one, 2 squares between that one. If you're going this way, 3 squares between this one, 3 squares between this one, 3 squares between this one, so on and so forth. Okay, so the scaling is right. Okay, you don't want to be sort of mixing the scaling too much. Okay, or at all, should we say. And then, okay, so just to recap, we discussed the straight line graph formula, y equals mx plus c. We've plotted our data. We've calculated the gradient of the line, okay, which is m, and we use this data to work out an unknown, okay, which was x. If x is 31, what is y? Okay, so I hope this helps. If you have any questions, please let me know in class. Thank you very much.